So the question 2, okay, you have to evaluate that the line integral using that Stokes theorem, because if not, you have to evaluate line integral along curve C1, C2, C3 three times. So it will be faster. We use a Stokes theorem. So this is sorry. This should be the double integral curl of f dot n ds. Okay, across that surface S. Okay, and this is the curl of f. Okay, by Sun. So component I you close this one. Cannot edit. Cannot edit. Okay, never mind. Okay, I'll just read it. Component I you close it and then you delta y squared minus delta z x squared. So this is 0. So delta y squared is 2y. So component I is 2y. Component j is actually I cross k. You have negative j. So you have delta x y squared. This is 0. Delta z 3y plus z squared. You got 2z. So negative minus 2z is positive 2z. Component k I cross j is positive k. So delta x squared, okay, delta x squared is 2x. Delta y 3y squared plus z squared, you have 6y. So 2x minus 6y, okay. So this is the curl of f. Curl of f is correct. The line integral f dot dr using the Stokes theorem is the flat integral, but the f is actually you have to change it become curl of f dot n ds. And then the curl of f soon have found here is 2y, 2z, 2x minus 6y. So you have, what is it now? 2y, 2z, 2y, 2z, 2x minus 6y. Okay, now want to dot with n. Okay, the formula have negative del z del x. Cos k when C1, C2, C3 traverse anti-clockwise using your right thumb, where the rest of the finger showing the direction of the curve, and then the right thumb will be pointing up. So the unit normal vector is pointing up. So the normal vector is negative del z del x I, then negative del z del yj, okay, dot with positive k. So you want unit normal vector, so divided by the magnitude of the normal vector, which is you have del z, each component you squared it, so del z del x squared plus del z del y squared plus 1. So this part is a normal vector. Okay, and ds, not enough space. Okay, ds, the formula is del z del x squared plus del z del y squared plus 1 dA over region R. So surface S, S is in 3 dimensions. So so ds will change it to 1 unit of the surface. This ds when you integrate it, so it become del z del x squared plus del z del y squared plus 1 dA over region R. The surface S will project it on the region the region R. And we simplify the square root. this square root and this square root, you simplify it. Then we have curl of f actually dot with normal vector. Region R. So this is 2yi, 2zj, 2x minus 6yk dot with normal vector, negative del z del x, negative del z del y, positive k, dA over region R. Okay, and now, okay, Soleha, just now, okay, I ask you what is your, okay, negative del z del x. Okay, Soleha, have you posted to the Telegram there? What is our normal?
Yes, doctor.
Okay, z x, correct. So to get the z from here, z is phi minus x minus y. So zx is negative 1, zy is negative 1. Okay, correct. And then negative again, negative del z del x, you got positive 1, negative del z del y, you got positive 1. So dot with, this is positive 1, positive 1, positive 1, dA. Okay. And then finding the dot product first. Then you have 2y multiplied with 1. I dot I is 1. Okay. And then 2z multiplied with 1. And then j dot j is 1. Okay. Lastly, 2x multiplied with 1. And then k dot k is 1. So you got 2y plus 2z plus 2x minus 6y dA. Okay, so this is double integral in terms of x and y. So z, you need to plug in back. What is z? Z is phi minus x minus y. Okay, so 2y minus 6y, you got negative 4y. Okay, plug in z here. Z, okay, from the surface given. So z is phi minus x minus y. Yeah? So 2 times phi minus x minus y plus 2x. Okay, dA over region R. Okay, expand and simplify it before you do the double integral. So 2 times phi is 10 minus 2x minus 2y plus 2x. So minus 2x plus 2x. Okay, so we just left y only. This region R. So minus 4y minus 6y minus minus 4y minus 2y minus 6y plus 10 dA over region R. Okay, region R is actually projection when z equal to 0. So when z is 0, you get x plus y equal to phi, or y equal to phi minus x. Phi minus x. And then you may find the double integral. We use the dy dx. You use dy dx, you need y. Okay, your vertical bar here touch, okay, from where, okay, up to where. Okay, so that's whether you understand. So Siti no Ashikin. Siti no Ashikin.
Yes, doctor.
Yeah, so what is the limit? Okay, your vertical bar here touch where? Or what is the lower limit?
0 to 1.
Okay, Siti no Ashikin is correct one. Y equal to 0 is because your x-axis y equal to 0. Horizontal line. If you said y equal to 1, also horizontal line. But do you have y equal to 1?
No.
We have this linear graph, right? Linear. This one. So this one already give to you. So what is that? Okay, your vertical bar touch x-axis, which is y 0, up to this, okay, this slanting line or linear graph.
Oh. Y equals to 5 minus x.
Yes, because if you say y equal to 1, okay, then you draw y0, y1 like this. And then if you say, okay, x0 up to x5, let's say x0 here, x equal to 5, then you get what? Rectangular region. Okay, so y0 is your x-axis. If you say y1, another horizontal line, and then later on you let your x0, x5, you get rectangular region. So this is wrong. So y is 0, x-axis up to this slanting line or linear graph, which is y equal to 5 minus x. Okay, so that's why the limit x is from 0 to 5, y is from 0 up to 5 minus x. So negative 6y plus 10 dy dx. Yeah. Because later on, okay, you will sum all the vertical bar if you divide, yeah, from the leftmost, which is x0, up to the rightmost, which is x equal to 5. That's why limit for x is 0 to 5. Okay, then you just evaluate the double integral. So when integrate respect to y, actually you don't have x. So you get negative 3y squared plus 10y. Put up limit for y 0 to 5 minus x dx. So negative 3, substitute y is 5 minus x squared plus 10, okay, minus x. Okay, substitute lower limit, everything 0. Okay, you may directly using the scientific calculator to evaluate it, or you want to evaluate manually. This will be negative 3 using u equal to 5 minus x. So du equal to negative dx. So that's why integral of 5 minus x squared dx, you will have integrate u squared, dx is negative du, so you get negative du, so you get negative u cubed over 3. That's why this is 5 minus x power 3 divided by negative 3. Yeah. So this 10 times, similarly, this 5 minus x squared divided by negative 2. Similar technique. Okay, or you may want, 5x minus x squared over 2 also can. Okay, and then limit from 0 to 5. So this one, negative 3, 3 cancel. So plug in, when plug in upper limit, 5 minus 5, we have 0. Here 5 minus 5 also mean everything 0. So upper limit, when you plug in x equal to 5, you get everything 0, because 5 minus 5 is 0. So minus, when you plug in x equal to 0, this is 5 cubed. Okay, and then this is, we'll simplify here, negative 5. So this is 5. How come the answer 0? 5 cubed, 5 cubed. The answer 0. Okay, let me check. Question 2. Question 2. Oh, the answer is 0. Correct. Okay. Or you may use your calculator. Yeah. Calculator, where is it? Where is it already? Calculator. Okay. Where's the integral? Here. Number 1, integrate. Okay, or you may directly using your calculator. So negative 3 times 5 minus x squared plus 10 times 5 minus x. Okay, from 0 to 5. So the answer is 0. This is directly using calculator, you obtain 0, or you use substitution technique. So this part, the same thing. So you see power 2, 5 minus x cubed divided by negative 3, power 2, 5 minus x 2 divided by negative 2, because this one negative x here. So du you get negative, okay, du dx is negative 1. That's why you divide by negative. So I think, so any questions here?